In part A, we need to find the change of period if the original is 4 feet. First, you need to write the equation. T equals 2 pi times square root of L divided by G. G is equals to 9.81 meters per second squared, and we need to change it to feet. So it's 32.185 feet per second squared. Then, we need to insert the given values into the formula. T equals 2 pi times square root of 4 divided by 32.185, which gives you as an answer 2.215 seconds. After that, we need to use the same formula, but for x2, which is 4.02, and we have t equals 2 pi times square root of 4.02 divided by 32.185, which gives you 2.22 seconds. In part B, we need to find the percentage of the change. We have T1 that is 2.215 and T2 that is 2.22, and our dx is 0.01. We're gonna insert these values into our formula. We're only gonna use T1 in this step, but first we need to derivate. T equals 2 pi times square root of L divided by G. 2 pi times L divided by G to the 1/2. We do chain rule to cancel out the 2's, and we get pi over square root of L divided by G. Now, we insert our values and we get pi over square root of 2.215 divided by 32.185 and times 0.01, and we get 0.12%. T is equal to 2 pi square root of length over gravity, then AT over dt is equal to pi times length over 32.185 to the power of negative 1/2. Then AT is equal to 1 pi times L over 32.185 to the power of a negative 1/2 times dt. Then you substitute length for 4 and dt for 0.02. You do the math in a calculator and you get AT is equal to 0.178, and that is your answer. If you have 2.21 seconds for every minute, how many seconds do you have for 1,440 minutes, which is the result of 24 times 60? The result is 3,190. Then you do the same but with 2.22 seconds, which the result is 3,197.62 seconds. Then you use the formula, which is delta x equals 3,197.62 seconds minus 3,190, and the result is 7.620 seconds. This means the clock isn't precise and it has an error of 7.620 seconds.
In this problem, we're going to integrate by substitution. We have to check that the powers are only 1 unit of difference. Then we must define u, which is the most complex. In this case, it's 3 minus x squared over 2. Then we have to find dx. which is dy, over the derivative, which is negative x. Now we substitute for dx. So we have x times u to the fifth power times dy over negative x. We cancel the x's and we're left with negative u to the fifth power. And now we can integrate, so we have negative u to the sixth over 6, which is equal to f of x, negative 3 minus x squared over 2 over the sixth power over 6 plus c, which is our constant. And that's our answer.